Hi students. As I told you yesterday, I want to solve some problems on Stokes theorem. As you know, Stokes theorem relates line integral to surface integral. Even Green's theorem also relates line integral to surface integrals. But the major difference is what? The difference in Green's theorem and Stokes theorem is in Green's theorem, we are going to consider the surfaces which are lying entirely on xy plane, whereas in Stokes theorem, it is not so. I can consider any surfaces, may not lie on xy plane in particular. So we are going to solve one such problems in using Stokes theorem. The problem says using Stokes theorem evaluate line integral over C, and it is sin z dx minus cos x dy plus sin y dz. What the we have to evaluate this, where C is what? C is given by 0 less than or equal to x less than or equal to pi, 0 less than or equal to y less than or equal to 1, z is equal to 3. So clearly, if I draw the figure, how it looks like? So it will be a surface parallel to xy plane. So this is y-axis, this is x-axis, this is z-axis. So x varies from 0 to pi. I take this as pi, this as 1, y-intercept as 1. So this will be my surface on xy plane, but z is 3. Z is 3 means what? Somewhere here. So I have to consider a surface which is on z is equal to 3 plane. So this is my surface. So this one, then from here, this one, then from here, like this. So this is my surface, z is equal to 3. So clearly here x value is 0, x value is pi, here y value is 0 and y value is pi. So this is my z is equal to 3. So this is the curve which is required. It is, as I told you, it is not lying on xy plane, it is parallel to xy plane. In the previous class we have already discussed, if the planes are parallel to xy plane, then clearly n cap is given by k cap. It is same as the normal to xy plane, which is k cap, and ds will be what? It is same as dx dy. So these two things are clear for me. Now n cap is k cap and ds is dx dy. So now what the Stokes theorem says? The Stokes theorem says closed integral over C f bar dot dr bar is equal to double integral over S. It is curl f bar dot n cap ds. Now of this n cap I know it is k cap, ds also I know it is dx dy. So since we considered the plane parallel to x-axis, our separate calculation for ds and the normal, they are reduced now. Otherwise what we should do? I should find out n cap using this one, del phi by absolute value of del phi. That gives me n cap, right? Then ds will be what? Dx dy, and what will be ds? It is dx dy over n cap dot k cap. So these two things are not there now because we are considering or the curve or the surface given is parallel to xy plane. So these two calculations, separate calculations, are not required now. So now if I look at the Stokes theorem, the left hand side says, left hand integral says closed integral over closed curve C f bar dot dr bar. But if I look at the integral which I was asked to evaluate, it is not in my required form. So how to bring this to the standard form? So I write now the given integral will be equal to what? Closed integral over C. Instead of sin z dx minus cos x dy plus sin y dz, I write this as sin z I cap minus cos x j cap plus sin y k cap dot dx I cap plus dy j cap plus dz k cap. So definitely if I go for the dot product, I get sin z dx minus cos x dy plus sin y dz. So now this will be in the required form. So this will be what? Closed integral over C. It is f bar dot dr bar. Right. So as per, therefore this will be equal to what? It will be equal to double integral over S. It is curl f bar dot n cap ds. Right. So in some of the problems you might find, instead of writing curl f in some of the books, you might find instead of writing curl f dot n cap, they can write this as double integral over S. It is curl f bar dot ds bar. Right. So what they did is this n cap times ds, n cap times ds, they have written as ds bar. That's all. That is the only difference. Right. Otherwise, curl f bar dot ds bar is same as curl f bar dot n cap times ds. Please note this. Right. Don't be panic if in some book it is written as curl f bar dot ds bar. Right. Now my next aim is what? I will find out curl f bar. I know n cap, I know ds. So n cap is what? N cap is k cap, ds is dx dy. Now I find out curl f bar. So now curl f bar will be equal to determinant I cap, j cap, k cap, then dou by dou x, dou by dou y, dou by dou z, then this is sin z minus cos x, next is sin y, this is sin y. So what this will be equal to? This will be equal to I cap times dou by dou y of sin y is cos y, dou by dou z of cos x is 0, minus j cap times dou by dou x of sin y is 0, minus dou by dou z of cos sin z is cos z, plus k cap times dou by dou x of cos x is minus sin x, so minus cos x is there, therefore this gives me sin x. Dou by dou y of sin z is 0, so sin 0. So therefore what is curl f now? Curl f will be equal to cos y times I cap plus sin cos z times j cap plus sin x times k cap. So I got curl f bar now. Now I have to, what is my next aim? I should find out curl f bar dot n cap. Therefore, what is curl f bar dot k n cap. So that will be equal to cos y I cap plus cos z j cap plus sin x k cap dot k cap. So that is nothing but sin x. So I got curl f dot n cap. I know ds, which is dx dy, right? Then see, now this is a rectangle, right? If z is equal to 3, it is above xy plane at the height of z is equal to 3. And what it is? It is basically a rectangle. So what are the x and y limits? So here itself I write x varies from 0 to pi, y varies from 0 to 1, because they are the rectangles, right? Now I go for therefore. Now I go for directly the evaluation. Therefore, double integral, that is given integral. So given integral is equal to integral over closed curve C f bar dot dr bar, which is nothing but double integral over s. It is curl f dot n cap is sin x, ds is dx dy. And I know the limits also now. X varies from 0 to pi, y varies from 0 to 1. So this will be equal to what? Y from 0 to 1, x from 0 to pi, it is sin x dx dy. So this is nothing but integration y from 0 to 1, it is minus cos x from 0 to pi dy. So that is nothing but this minus sign I take out, minus 0 to 1, it is cos pi minus cos 0 dy. So this is nothing but minus 0 to 1, minus 1, cos 0 is minus 1 dy. So that is nothing but minus 1 minus 2, with this minus becomes 2 times 0 to 1 dy, or the final answer is 2. Therefore, integral over c, it is sin z dx minus cos x dy plus sin y dz will be equal to 2. This is my final answer. So now in this lecture you came to know about the Stokes theorem, how to solve the problems using Stokes theorem. And one more thing you came to know is what? This double integral over s, this curl f bar dot n cap ds, I can replace this by ds bar. This also you came to know. So don't be confused if curl f in some problems. You may get the problems curl f dot ds. Evaluate curl f dot ds. So ds bar. So we came to know that this ds bar is nothing but it is n cap times ds. That is the second thing. And the third thing is what? How to find out ds and how to find out the normal. So if we have to find out normal, I should find out gradient of the function, then divide by its absolute value or its magnitude so that I get the unit normal. Then ds will be what? It is dx dy over n cap dot k cap. So ds is ds dy dx dy over n cap dot k cap, and n cap will be what? It is del phi divided by its magnitude. So that will be n cap. So these things you must know. That is one thing. The other one is, see, now the problem which we discussed just tells me about evaluate the following integral, this integral, using Stokes theorem. Instead of this, suppose if the question is verify Stokes theorem for this particular integral, then I have to see, now you know how to find out the double integral. Along with this, so this becomes my RHS. So RHS is what? It is 2 now. Now I have to consider the surface integral also. I should consider integral over c sin z dx minus cos x dy plus sin y dz on this, on all these boundaries. That is, I can say a, b, c, d. I should take the curve like integral over ab plus integral over bc plus integral over cd plus integral over dA. Then I have to add them up and I have to find out that integral. That gives me my double integral f bar, line integral f bar dot dr. So this value and my answer I got, that two, they should match each other. Then only that verification is done. So if the questions are of two types. One is evaluate using Stokes theorem. Then what you should do? You should find out the surface area, then find out the projection of that surface on xy plane, then find out ds, find out d phi, then fix the limits, evaluate the double integral. That's all. That is, you are using Stokes theorem. You are converting line integral to double integral and you are evaluating. Right? Instead of that, suppose if it is asked verify Stokes theorem for such and such, then I should find out the line integral also, I should find out the surface integral also, and I should match them. If they are equal, that indicates the Stokes theorem is verified. I hope you enjoyed my lecture. Again and again I am telling the same thing. Don't go out of your house, confine to your house. Better go to different lectures because so many courses are available on NPTEL. If you go to MCW courses, that is Massachusetts Openware courses, that also is available. It is also free of cost. NPTEL is free of cost, so you can go through those online lectures and you can understand, because you should utilize such facility, because you need not go to the college. You are saving time there. You can't go outside also. Sitting inside and it's very difficult. I know how difficult it is to spend time. So use this time effectively. Understand the essence of maths. As I told you, if you are good in maths, definitely I bet you are good in all the other courses, because maths enhances your, it is like a tonic for your analytical ability, right? So with this I conclude today. Next topic will be on Stokes theorem. Thank you. Good night.